Okay, welcome everyone to week 3 of WOOFCODE. Confusingly, week 3, despite it being actually the 4th week. In this lecture, we'll actually figure out why we did that. The short part of it is basically computer scientists always start counting from 0. So we'll see that in action this lecture, and hopefully that seems a little bit less weird. So last week's homework, last week's lecture, we were talking about the fundamental building blocks of JavaScript. So lots of new syntax. We learned about variables, we learned about operators, we learned about types, and we learned about functions. If you did the bonus homework last week, you might get the feeling that some of these problems were kind of contrived, didn't really make that much sense. So we didn't really learn enough syntax to be able to do something sort of substantial as a problem with JavaScript. But at the end of this lecture, we'll be sort of rounding out a lot of other syntax that we might need to know for JavaScript, programming principles in general that should come in useful. And this week's bonus homework will actually have some really interesting problems for you to solve. So you'll hopefully feel like a real programmer by the end of this week. Okay, so what we're going to cover this lecture, part of it will be control flow, also called conditionals, which allow us to put if-else logic in our programs. So if something happens, then run this line of code. If something else happens, run this line of code, which is sort of a fundamental part of any programming that we really want to do. To get to control flow, we'll also be talking about Boolean values, which is the last data type that we didn't cover last lecture. We'll also be talking about loops, which allow us to do some lines of code repeatedly until some condition is met. And then finally, we'll introduce arrays and objects, which are two different types of data structures, which you can essentially think of as like a supercharged super variable from last lecture. Okay, so the first thing I want to talk about is control flow, also called conditionals, because something can happen in a particular condition. The name control flow, it's one of these like weird names that seem to come with everything in programming. Essentially, we're sort of like controlling the flow of a program to do different things in different cases. So this image that we have here on the right, we have a forking path. We can go one way or another. This is essentially what a control flow thing lets us do. So to learn about control flow, first we have to talk about Boolean values. So we might remember this slide from last lecture, talking about all the different primitive data types that we have available, all the different sorts of things that we can put into boxes. And we talked about numbers, we talked about operators, which are things that we can do with numbers, which is basically just basic maths, adding things, subtracting things, timesing things, dividing things. We also talked about strings, which are strings of characters, pieces of text. And again, we talked about this concatenation operator, which is just plussing two strings together, basically. And we vaguely covered these two, but that's about as much as we're going to talk about these two in this course, because they're not all that important. But we have one more type that we need to talk about, which is a Boolean value, which is something that is either true or false. And the syntax for writing one of these Boolean values is that there's a special reserved word for true and a special reserved word called false. So again, just like the word let, just like the word const, just like the word function, we can't use the word true as a name of a variable, because true is a value. True is something that JavaScript understands as, oh, okay, that's like one of these Boolean values that we can have. So, okay, so that's true and false, simple as you write the word true, that's going to be like yes on existing. False is not there, off, not existing. And we can make lots of logical distinctions in our program using these two concepts. So we have lots of different operators that we can use with Boolean values. So an operator, again, just something that we can do with the type. So, arithmetic operators is just, okay, plussing two numbers together. Don't get too worried by the name here. It sounds complicated. This is actually kind of easier than it looks, these comparison operators. So we can use two equal signs together to signal equality. So all of these comparison operators, by the way, they'll take basically two numbers and they'll spit out a Boolean value. That's all of these comparison operators, basically. We can plug together two numbers and come up with a true or false statement. So the way that this works is, okay, with two equal signs or three equal signs, basically both of them, we can plug in two numbers and we'll return true if those two numbers are the same value. We can also use this for strings, the equal signs. Remember again from last lecture, we use one equal sign for assignment. So, let variable equals some value. If we use two equal signs, then that's asking for equality. So A, two equal signs, and B is saying, okay, are these two values equal? And if they're equal, then that evaluates to true. Then putting an exclamation point before these equal signs is sort of like the reverse. So in general, like an exclamation point in programming is like not. So exclamation point equals is not equal to, and then exclamation point two equals is not identical. So there's a slight distinction between these two, between equality, and identity. So if we use two equal signs, the distinction is we're checking if the sort of shape of these two things is the same. With identical, we're also checking the type. So the one area that this comes up a lot is when we're trying to determine whether a number and a string of a number are the same. So for instance, if we had the number 1 and we use this operator to determine does the number 1 equal a string of 1? With two equal signs, that's true. Like they're both basically 1. Who cares about the type? We'll just sort of convert that to make sense. But if we're using these three equal signs, also known as strict equality, then that will return false because, okay, that's the same number 1, but this one's a number and this one's a string of a number. So that returns false. So that's the first 4 here, not super complicated. Looks like there's lots of stuff because there's lots of text on the screen, but it's not too bad. And then these last 4 are pretty straightforward as well. Basically, we're comparing between two numbers, number 1, number 2. And when we have this less than or equal to sign, we're checking for, okay, is number A less than number B? And if that's true, then it evaluates to true. Greater than or equal sign here, we're checking, okay, is this number greater than this number? So you could imagine, okay, like 3 and 1 here, that evaluates to true because 3 is greater than 1. So hopefully these are all fairly simple. Then the last 2 here, if we do less than or equals to and then equals, that's checking, okay, is this number less than or equal to this number? So if we had, okay, 1 and 1, we'll say, okay, is 1 less than or equal to 1? Well, it's equal to, so that evaluates to true. If this was, okay, 1 less than or equal to 0, then that would be false because it's neither, wait, no, that would be true. Okay, if there was 1 is less than or equal to, yeah, okay, if it's 1 less than or equal to 0, that would be false. 1 is not less than or equal to 0. Okay, so just really simple comparison stuff. Maybe you've done something like this in maths classes before, or hopefully this less than or equal to stuff, less than, greater than, isn't super complicated. We can pick this stuff up fairly simply. Okay, so okay, so we introduced Booleans, we have these comparison operators. It turns out that some values, we'll rewind for a second. Okay, so if you try to use pretty much any value in a Boolean context, so if we're trying to do an equal sign or a less than sign, and one of these values isn't a Boolean, so let's say we have, okay, no, that's not a good example. I'll just do this slide first, okay. Okay, so we have other operators as well. We have the comparison operators, which is like, okay, we use true of some other data type and we get back a Boolean value. We also have what's called logical operators. And the deal with logical operators is that we can give them two Boolean values. So this could be true here and false there, or it could be true there and true there, or it could be false there, false there. We give two Boolean values and we get back one Boolean value, which is sort of like the evaluation or the combination of both of these Boolean values. So we can use these two ampersands here. This reads as and. So the way to think about logical operators is with and, both of these have to be true for it to evaluate to true. If one of these is false, then we can say, okay, both of them are not both true. So both of these has to be true in order to evaluate to true. With two sort of like dashed vertical lines, this evaluates to or basically. So two lines going this way is or. So or is sort of like the opposite of and. With or, just one of these values has to be true to evaluate to true. So if we have false and true, that evaluates to true. If we have true and false, that evaluates to true. But if we have false and false, that's the one scenario where this evaluates to false. And then, okay, if we use an exclamation point and then a Boolean value, that's sort of like the negation of whatever that Boolean value is. So exclamation point false is true, exclamation point true is false. Okay, so that's all of the operators that we have to work with Boolean values. I think now it makes sense to come back to this slide and say, okay, if we try to use something that's not a Boolean value in the context of where a Boolean value is expected. So for example, if we put in a string here, like hello and false, then our JavaScript program or browser is going to read that value as true for pretty much anything. Pretty much any kind of data type that we pass it. It will just assume, okay, they must mean true. But there's a few exceptions. With a few different types of data, our program is going to read that as false. So for example, here we have a few examples. When we have an empty string and we try to use an empty string in a Boolean context, then our browser is going to read that as false. When we have the number 0, we try to use that in a Boolean context, browser thinks that's false because there's basically nothing there. Same kind of logic with this empty string. It's basically nothing. Let's read that as false. There's nothing there. It's not something. Also with an uninitialized variable, if we try to use this in a Boolean context. So uninitialized, we have this special data type called undefined. And undefined is basically also like, okay, there's nothing there. So that's false as well. And then finally, the last two, null and NaN. If we try to use these two in a Boolean context, then that evaluates to false. And then, yeah, everything else will evaluate to true. Absolutely anything else is true as far as JavaScript is concerned. And again, yeah, so don't mix these up. We mentioned this last lecture, but I'll mention it again. One equal sign is assignment, so put this thing into this box. Two equal signs is equality, so roughly are these two the same thing? And 3 equal signs are identity or strict equality, where we're checking, okay, is what's in the box the same for these 2 variables? And is the type the same as well? Okay, so I'll do a little bit of a demo here. Here we are back in the console, just on the WOOFCODE website. We can write JavaScript right here in the console, so we can play around with some things. And so just to get a bit of an understanding, I'm going to make a console log of true, 2 ampersands, false. Okay, true and false. So the deal with these 2 ampersands with the AND operator is both of these things have to be true in order to evaluate to true. So here, one of these things is true, but one of these things is false. So not both of them are true. They're not both and true. So we get false. If I instead decided to write, let's say, hello world, the best dummy text that we can imagine. Hello world, double ampersand, false. We'll see that we also get false. The reasoning is this is something which isn't a falsy value. So JavaScript interprets that as true because we're trying to use a Boolean operation on this value. So essentially we get true and false, which then evaluates to false because they're not both true. Okay. If instead I wanted to use, okay, 0 and then false. Okay, there's some weird stuff going on with 0, but I think if we use this, okay, no, this doesn't work out correctly. I haven't quite understood this. Okay, I think we'll come back to this with conditionals because I think this makes more sense of when these things get contorted one way or another. I can use at least, okay, not 0, and this gives us true. Okay, so JavaScript in this case, we're giving it something that's a falsy value, so that's either 0, empty string, NaN, undefined, or null. And we're saying, okay, not null, so using this as a Boolean, and then ultimately we get, okay, the opposite of a falsy value, which is true. Okay, with this stuff, I have a vague idea of why this is happening. This is something kind of weird with JavaScript, but let's not worry about that for now. I promise you if you use this in an if statement, which we'll talk about next, then we need to be wary that most things evaluate true, otherwise we get false. Okay, in falsy values. Okay, so next thing, now that we have these things called Boolean values, which is either true or false, we can manipulate these Boolean values using comparison operators and logical operators. We can actually do something with these Boolean values, which is really useful, which is this whole conditionals thing or control flow thing. And the deal with conditionals is that we can use something called an if statement. And with an if statement, we're passing in a Boolean value. And if this Boolean value is true, then we'll run the code inside of these curly braces here. So we have an example here on the right. We have an age. We have this variable called age, this box. We're putting the number 30 inside of it. And then here, we're using this comparison operator to check whether this age value of 30 is greater than the number 18. So in this case, we have 30 is greater than 18. That's true. That makes sense. 30 is greater than 18. So since this evaluates to true, we're executing this code down here, and we're logging out, okay, you are an adult. You're greater than 18. Okay, so we have that if statement. We can run this code only if a certain condition is true. We also have something called the else statement, which we can optionally put after this if statement. And with an else statement, we'll say, okay, if this condition is true, then as usual, we'll just go through this if block. We'll log out, okay, you're an adult again, same thing. But with the else statement, we can sort of catch the opposite of what happens here. So if age is greater than 18, if this condition is true, then we log out this one. But if this is false, then instead we're executing this code down here. Then another thing that we can do as well, we have the if statement, we have the else statement. We can also use this else if statement to add more conditions on top of the top one here. So in this case, the same sort of rough idea again. We have these different age divisions. We'll say, okay, if you're greater than 65, then we'll say you're a pensioner. This else if condition here, so this is in the case that somebody isn't over 65. So we're going to say, okay, else if the age is greater than 40, then we'll say you're middle-aged. So sorry for the older people in the course. This really isn't meant to be mean or discriminatory. You can feel as old as you like. That's totally okay. I don't want to put any judgments here. Okay, so this is checking essentially, is somebody between 40 and 65 because they're not over 65. And here we're checking, okay, since you're not over 65, are you over 40? So this is 40 to 65. If the age is in that bracket, then we get console log of you're middle-aged. Okay, then we're checking, okay, you're not over 65, you're not over 40. Are you over 30? In this case, we get this one. And then when we're also checking, okay, are you older than 18? So that's between 18 and 30, between 19 and 30, essentially. Okay, and then we have our else condition as usual, which covers the case essentially if somebody is 18 or younger, or we're saying, okay, you're not an adult. So in this case, okay, age is 30. We hit the first condition here. Okay, is the age greater than 65? That's false, so we keep going to this else if. We're checking, okay, is the age greater than 40? And it's not, 30 is not greater than 40, this is false. So we keep going. Then we're checking, okay, is your age greater than 30? This is also false, because 30 is not greater than 30, it's greater than or equal to 30. So then we go to this one, and it checks, okay, is the age greater than 18? And this ends up being true, so we execute this block of code here. So we get this console log of you aren't a child anymore. Okay, so using these logical operators, we can put these logical operators inside of these if statements here, and we can essentially combine different checks to create one check that decides whether the if statement runs. So in this case, we have two variables. We have age, and we have a Boolean value of whether that person passed a driving test. And here we're saying, okay, if this person's age is greater than 16, so this is going to evaluate to true or false. And if this value is also true, then we're going to run this statement here. Otherwise, we run this one. Just telling this person, okay, are you allowed to drive or not? So in this case, okay, age is 30. So 30 is greater than 16, that's true. Past driving test is also true. And we're using this AND operator. So both of these values are true. So this code at the top gets to run. So you are allowed to drive since both of these are true. Okay, so that's control flow. That's a really quick introduction. You'll get some more experience with that in the homework this week. And I think it's one of these things that you get so much better at just from practicing. So if it seems a little confusing at first, if there's lots of new stuff to figure out with all these new operators, don't worry about it. It'll come with practice. But you have a really, really rough introduction here that actually allows us to do quite substantial things in terms of programming power, which is great. Okay, so the next thing I want to talk about is loops. So loops allow us to do something continually again and again until some condition gets met. So there's lots of borrowed syntax, borrowed ideas from the stuff that we just learned with conditionals and if statements. And with that in mind, the first loop that I want to introduce is the while loop, which looks almost identical to an if loop. With an if loop, we're checking, okay, does this condition equal true? And if that condition equals true, then we run some code in between these curly braces. With a while loop, it's exactly the same, except the while loop will just continually keep executing the same block of code until that condition ends up being false. So in this case here, we've got a fun example. We have this variable called bottles of beer. We're setting it equal to 99. And with a while loop, okay, we check the condition, is 99 greater than 0? That ends up being true. And then we run this code. So we have, okay, console.log, 99 bottles of beer on the wall. And then we're decrementing this value by 1. So we're setting this value again, we're reassigning this variable to the current value. So that's 99 here, 99 minus 1. So this is the bottles of beer now equals 98. And then once this code block is finished, then we check this condition again. So this time we have bottles of beer, which is 98. And 98 is still greater than 0. So we run this code one more time. And then this time we have, okay, 98 bottles of beer on the wall. And then we're setting bottles of beer to 97. This keeps going all the way down until bottles of beer is 0, when we no longer need to run this code block anymore and the program continues. Okay, so that's while loops, super similar to if loops. The one thing we need to be careful of is that if we don't somehow change this value that we're using as a counter here, then this loop will simply go on forever. So if we didn't have this reassignment here of this bottles of beer variable, then we would just have the console logging 99 bottles of beer on the wall for an infinite amount of time. And sometimes this can cause memory problems. Sometimes this could crash your computer. But luckily with JavaScript, it never really gets that bad. So we need to make sure that at some point, this condition is going to equal false. Otherwise, it's just going to run forever. Okay, so that's while loops. That's the first type of loop that we can make that does something continually. And this is generally a good idea. If we wanted to do some complex program that does something 100 different times, we don't want to be rewriting the same lines of code 100 times. It's way better if we can abstract that into a loop, which can save us some copying and pasting, make things a bit cleaner. And it can also let us do some more sort of dynamic things, changing values depending on function inputs, things like that. Okay, so that's a while loop. The other loop I want to introduce today is a for loop. So for loops are kind of similar. We're checking some condition, and if that condition is true, then we're running some code. The deal with a for loop in pretty much every programming language, also in JavaScript, is that we have sort of 3 parts to it. The first part is what's called an initialization. So we're creating some new variable and we're setting it equal to some value. In this case, okay, we're calling the variable I. That's always the thing that people go to. It's always an I. I stands for index, or I stands for increment, maybe. Yeah, iteration, something like this. We always call it I by default. We have this variable called I. This is like the condition part. So every run of the loop, this is what it's checking. So we're checking, okay, is I less than or equal to 10? And then the final part is the update. So this happens after every loop gets run. So to go through this as a whole, to try and read this as our browser reads it, we hit this for loop, we create this new variable called I, we give it an initial value of 1, then we run the condition. So we say, okay, is I less than or equal to 10? And okay, since 1 is less than or equal to 10, we get to execute this block. Then we're console logging 1. Then after that, we're updating the value of I, say with this I++. And now I is equal to 2. 2 is less than or equal to 10, so we run the block. We log out 2. Then we plus 1 to that value. So now I is 3. I is less than or equal to 10, so we run the block again, console logging 3, and so on until we reach 10, at which point we add 1 again, which is 11, and then 11 is not equal to 10, so the loop ends. So that's the full loop of how this works. We might not have seen this syntax before. It turns out that we can use this syntax to add 1 to a number. This is like one other fairly niche operator that we can use with numbers. So this is basically exactly the same as saying I equals I plus 1. This is just a little bit shorter, and especially in this for loop, it makes things a bit cleaner. And these three are also 3 different statements. We can see that these statements are sort of separated by these semicolons. Some people, by the way, will insist that you use semicolons after every statement in JavaScript. I'm not one of those people because I'm fairly lazy and I think it makes things look a lot uglier. But essentially we have these 3 different statements that the for loop is using at different times. Okay, so again, all we have here is initialization. We have the check, the condition to see if something's true. And then we have the iteration. What are we doing to the value every time? And this doesn't always have to be plussing 1, but generally it's either, okay, plus 1 to this value or minus 1 in order for us to make a loop that lasts a certain number of times. Okay, so we can add logic on top of for loops to do some interesting stuff here. So this is a really famous programming game called FizzBuzz. And the deal is that it's counting from 1 to 100. And if the number that you're saying is a multiple of 3, you say fizz. If the number that you're working on is a multiple of 5, then you say buzz. And if it's a number that you're working on that is both a multiple of 3 and 5, then you say fizzbuzz. So the challenge is to make this work from 1 to 100, which would look something like 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, fizzbuzz, for example. So if it's just a multiple of 3, then you say fizz. If it's multiple of 5, you say buzz. If it's both 3 and 5, then you say fizzbuzz. So again, we have this loop set up that's basically iterating, running this code for the numbers 1 to 100. We're initializing I to 1, so it starts at 1. As long as I is less than or equal to 100, we're going to keep running the loop. And every time we run the loop, we're going to add 1 to this I variable. So we're using this modulo operator that we talked about last lecture, which is pretty much only used for like little problems like this that you can do in a programming interview. But okay, so the deal with the modulo is that we divide the first number by the second number, and it gets back the remainder. So so this is checking. Okay, is this whole condition here is basically checking, is this number a multiple of 3? Because when this number is 0, when the number divided by 3 has 0 remainder, then that means it's a multiple of that number. And there are other ways that we could have written this. We didn't need to use the modulo operator to get this to work, but this is just quite a neat, easy way of doing this. Okay, so if it's a number between a multiple of 3, then we're saying fizz. If it's a multiple of 5, then we're saying buzz. We should have started, actually, this is actually kind of wrong. We needed to start this with an if statement checking if both of these are true. And if that's true, then we should write fizzbuzz in 1. So there's a little bit of an error here. This actually doesn't work totally properly, but it does sort of half-gate you there. And then otherwise, we're just going to count the number. So if we're not saying fizz or buzz or fizzbuzz, then we just put the number there. And that's how this, so that's like a cool little thing that we can do with this program now that we couldn't have before. Last thing with for loops, we can use the break statement, just writing the word break, if we want to cut out of a loop on a certain condition. So this loop again, we're just counting from 1 to 100, the same way as before. We're console logging, okay, searching, and then the current value. And if this value equals 42, then we're console logging, okay, we found the number, and then we're stopping. So in this case, this is going to count out 1, 2, 3, 4, blah, 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 all the way to 42. And then when we reach 42, we're going to stop counting, and we'll just say found it. So this can come in handy in some situations to make our lives easier and not do too many more loops than we really need to. Okay, so that's loops. The last thing I want to talk about today is something called data structures, which are basically two different things. We either have arrays or we have objects. And the way that I want us to think about data structures is they're sort of like supercharged super variables that let us store more things in sort of one box more efficiently. So I have a few images that we can use to talk about this. So from last lecture, we said that a variable is sort of like a box. It's something that you can put some value in. And if we did something like, okay, let myvar, just let myvar is basically saying, okay, give me an empty box. So it's sort of like, okay, we have a box and we're putting a name tag onto that box with whatever we named it, in this case, myvar. And we can then put things inside of the box and then access them later. So we could say, okay, let myvar equal 2, the number 2, and then we could add that variable later on to another number. We can pass it around, and we sort of keep track of different information in our program, which is really nice, which makes programming way easier and allows us to do lots of other things. We're basically storing things in boxes. So an array is sort of like a mega box, which is subdivided into smaller boxes like this. So again, we can store an array in a variable. So we could say my array equals some array. And then it's kind of like we have this sort of giant super box where we have different slots that we can put things into. So an array is sometimes talked about as sort of like an ordered list, which just means the order that you put things into boxes like this matters. And then we can retrieve things by using the index, which starts from 0. So I mentioned at the start of this lecture, we'll finally figure out, okay, why does this course start at week 0? In general, with programming, we think of 0 as the first positive integer for some reason. I'm not totally sure why, but by convention, pretty much everything starts from 0 rather than starting from 1. I think that's easier to do some calculations and easier to work with on the kind of the raw like on the hard drive level. For some reason that's beyond me. So an array is sort of like, okay, a super variable where we have lots of different boxes that we can put things in. And this super variable will just extend as much as we need it to. So there's no particular fixed length. Here we have an array of length 4, but we could easily put more of these boxes alongside each other. And then we have this nice giant little package that we can use in our program, and we can store all of these different things in this array. So that's really nice. The other type of data structure that I want to talk about is an object. So an object is sort of similar to an array in that it's sort of like a super variable that we can put other variables inside of. Except an object is sort of like a box, a giant box with other boxes inside of that box. So here we're saying, okay, we have the box as a whole, the object as a whole, we're calling my object. We have a variable that we're putting an object in, and we're just sort of writing the name tag on front of the box. And then we can put stuff into the box. But what we're putting inside of an object is sort of like more variables. So sort of like more boxes inside of the box. We can store as many boxes as we like inside of this giant box of boxes. And we can also give these inside boxes, interior boxes, their own name tags. And then if we want to grab a box inside of this box, we can look that up within that box. And I'll show you the syntax of how to do this in a few slides. Okay, so that's just try and make things a little simpler. Like, why are we talking about these data structures? Why do we need these data structures? They're just more advanced, more useful ways that we can store different types of data rather than having an infinite amount of boxes that we have to keep track of. Okay, so arrays. Let's talk about the syntax. Here's what an array essentially looks like. We have sort of these square brackets surrounding an array, and we just need to put different values in each slot, essentially. So the ordered lists, which means value 0 here, the first thing that we're putting in is always going to be retrievable by the 0th index. And we need to keep track of which position each of these values live in, basically. So as an example here, different types of values that you can put into this array. Here we have different strings, an array of strings. Here we have an array of numbers. And it turns out that we can put different types of things in an array as well. So it's not like if you have an array of numbers, you can only put more numbers in it. You can put anything at any position in these boxes. So it is literally like, okay, we can just make more boxes connected to this giant centipede of a box. And that works totally fine. Lots of languages you can't do this. Lots of languages you have to explicitly declare, okay, is this like an integer array or is this a string array? So that's something quite nice about JavaScript, is that it allows this level of flexibility. Okay, we have something called the length property, where if we write out the name of the array, the variable in this case that we're storing the array, and write .length after it, this returns how many items are in the array. So in this case, this would evaluate to seven colors of the rainbow. That's a handy method. It turns out that we can also do this with strings. So if we had red in quotes and then .length, it would return 3, which is kind of helpful. If however many characters are in the string gets returned by length, which is nice. Okay, so if we want to use one of these sub boxes in this giant mega box, so if we want to get something out of one of these boxes, we use what's called the bracket notation. So we use the name of the variable and a bracket and then one of the numbers, which is the index in the array, like the count in the array, will give us back the item inside of that array. So again, we start off at 0 in JavaScript. So the first one is 0, the second one is 1, the third one is 2, and so on. So here we're saying, okay, rainbow colors of 0 in brackets, 0 in brackets. It's the 0th index which is the first item in the array. So this first color variable evaluates to red. And then here we're saying, okay, rainbow color 6 with the bracket notation. This will get us the 7th color in the array, which is violet. So yeah, we can just think of this as a better storage mechanism than writing all of these strings out in their separate colors. And it's sometimes quite useful to be able to group these sorts of related things into one block. And especially tying this into arrays, into loops, which we'll talk about in a few slides. Okay, so just like with a variable, we can access whatever's there just by adding brackets on top of it. And it's really similar to using a variable actually with editing an array, with changing one of the values. So here we have an array with strings and numbers and everything. Essentially what we're saying here is get me the sub box stored at index 0, which is the first item. And we're using the equal sign in the context of reassigning. So again, equal sign is always change the value of the thing on the left and put the thing on the right into that thing. So in this case, we can imagine just like with a variable where we're reassigning something, this will essentially go in here. It will kick out whatever value we have inside, and it will put this new value in its place. So doing these two lines together, we'll end up with salad 42 Rick and Morty rather than pizza. So that should hopefully be refreshing to realize the connection between changing values in arrays and changing values in variables. They're basically the same thing. We can also add new items into an array. We can add new items in an array by using this push method. So if we take the name of an array and we write .push and use these two curly brackets and put something else in here, it'll add this thing onto the end of this array. I'm going to talk about what exactly this is in a couple of slides because I think it's quite interesting and quite useful to understand. But yeah, this is how we create another box on the end of our array that we can put more things into. We just need to use this push syntax to add something on the end. And yeah, so we can use arrays and loops together to do pretty cool things, especially starting in next lecture where we're connecting real websites with JavaScript code that we're writing. We can do things like iterate on lots of different elements on the screen and do things repeatedly. And just having arrays and using them together with loops will come in handy quite a lot going forward. So we can iterate through arrays with code that looks like this. This is a pattern that you'll see quite a lot in the next few weeks. It turns out there's an easier way of doing this, which I'll explain, I think, 2 weeks from now or 3 weeks from now. But I think it's good to get in the practice of seeing how these loops work and thinking about how these loops work together. So I'll show you this. Essentially, we're starting from 0. We have this array here. And we're in the condition of this for loop here, we're checking if this variable that we just created, I, is less than the length of this array. And then if that's true, we're going to run some code. In this case, just logging out what is at the position I of this rainbow colored array. So first time, we're going to set I equals 0. 0 is less than 7. So we're going to run this code, and we're going to get the item at rainbow colors index 0, which is red, and we'll log out red. Then this keeps running continually, repeating on and on and on with this loop stuff. It's quite slow. But okay, so we have 0, we log out red, Then we plus 1 to that 0, so I is 1. 1 is also less than 7, so we're logging this again. This time we have rainbow colors at index 1, which is orange. And this will continue so that we log out everything that's in this array. So we can use these together quite nicely to be able to do something for every element in the array. And we'll use this pretty frequently going forward. Okay, so that's arrays. The other data type I want to introduce is an object, which once again is sort of like a giant super variable, super box that can contain as many boxes inside of this box as we need. This is the syntax. We're using the curly brackets to encapsulate an object. Remember, we use the square brackets for arrays. Objects is curly brackets. And the way that this works is that we have a name of a property. So the thing on the left is a property. This is the technical term for it. Properties and values. Property is the thing that you're setting. A value is something that you're putting into that thing. That's the same syntax, same wording as we used for CSS. We had properties and values. So the color property we could set to red, for example. And then we split each property that we're defining with a comma. So don't worry about getting all of the syntax right, memorizing all the syntax. When you get started, you'll always be looking things up, always be saying, okay, what was the syntax for object? What was the syntax for array? That's totally normal, totally okay. Don't feel as though you need to absolutely memorize absolutely everything to be able to start programming. This totally comes with experience, and yeah, the first year, maybe even when you're using this stuff, you might need to look things up every time. That's totally okay. Okay, so in this example here, we have 4 different properties, and so yeah, here we're saying hometown equals York, UK, hair is short, likes is, in this case, an array. That's totally okay. A value can also be an array, or it can also be an object, just like any variable, basically. We can put pretty much anything we want in this value field, and that's totally okay. In terms of accessing a property of an object, we can either use the dot notation. So the name of the object dot the name of the property will give us that value. Or we can also use the bracket notation in the same way that we were using for arrays. With the bracket notation, we have to be careful to use a string rather than just a name. If we don't have these characters in string form, then our browser is going to try and use some variable to put in there that doesn't exist. So it's going to return undefined. So two ways that we can access objects, dot notation and bracket notation. Changing objects, same again. So we can really think of using the dot notation to grab a property is just like using the name of a variable to grab a variable. So just with arrays, where we can say, okay, assign this value into this sub box, the sub box that's at index 0. Again, we can say assign this value into this box called hair inside of our user object. And that kicks out what we have already and replaces it with the new value, just like with a variable. And we can also just add new properties onto an existing object. We can do this as much as we like. It's really easy. No problems with that. So here in this case, we have this user object, and we're adding a new property. A new box gets created inside of the mega box of an object, and we're putting the value of false inside of that box. Okay, it turns out we can also have arrays of objects. This is quite a common design pattern for programs. So in this case, this is a really good example where we're defining an array of users. So this could be a range of different users that are using our app, using a web app. And we can have different fields for each of these users. So in this case, we just had one user that we wanted to do something with. But in this case, we can do something for every user at one at a time. So we're using this trick with this for loop that we were talking about a few slides ago, where we're iterating over this list of users, over this array of users. And for each one of these users, we're logging out, okay, this user's name is, the user's name is whatever the user's age is, years old. So first example, I'll just go through the first item here. I starts off at 0. So 0 is less than 2. So we run this code block and we're saying, okay, give me a variable which just grabs the first item in this array. Because I is 0, so uses 0, it gets us this one. And then we're console logging, okay, the name of the user is Jolene, is 21 years old. So that's what gets output to the console. And then the second time around, it's 1, so it's Alexa instead, who's 18. Okay, so this comes in handy quite a lot. We can pass arrays of objects into loops. We can do things with an array of objects. We can manipulate multiple different entities at once, which really adds a lot of power onto what we can do with these programs. We can also pass objects as arguments into functions, which is also really useful. So in this case, we have a function called describeUser. It expects a user object like this, and it will log out, okay, you are certain number of years old and you have a certain hair color, for example. So here we're saying, okay, describe user Jolene, we're invoking this function, and then we get back, okay, Jolene gets put into this input of the function, and then we get the console log of you are Jolene's age, you are 21 years old with auburn hair. So in this case, rather than having to rewrite everything for every single user, or instead of having to pass in multiple different arguments like the user's age and the user's hair, we can do it all really succinctly in one go by passing an object into a function. Okay, so the last thing I want to talk about today is what's called an object method, methods of an object. Okay, so we have these boxes here, and we can put anything into a box. It turns out we can also put a function into a box. And we can use syntax like this. So this is called an anonymous function, where we don't have to give it a name. And the deal is we're creating a new box, and we're filling that box with this anonymous function. And we can then call that function just like a real function. So in this case, we're creating this box called talk, and then we can access that using the dot notation with jolene.talk. We have the two parentheses because we're calling the function that's stored inside of it. And in this case, okay, calling talk gives back, okay, howdy, I'm Jolene. And we can also reference things inside of the object with this notation. Actually, we're not doing that in this lecture. I think we're going to do that in 2 lectures' time. Okay, but we can also pass arguments in. Same with a normal function. Inside the parentheses, we can give values, and then that function is going to use that value to do something different. So if we call jolene.eat, passing in pizza, we'll get back, okay, yum, I love, plus pizza, essentially. Okay, the last thing I want to mention, I talked about push somewhere. Yeah, this arrays push method. So anything that we're attaching to an object that's a function is technically called a method. And we've seen this a few times already, actually. Like this console.log, the log is a method on this object called console. And in JavaScript in general, under the hood, pretty much everything is actually an object. So when we create a new array, that array is actually an object, and that object has a method called push. So just to give you a quick example to demonstrate this, we can say, just clear this console. There's a special function that we get from JavaScript called typeOf, which checks the type of whatever we put in. So we'll say type of hello, this is a string, type of 34 is a number, and so on. I'm going to create a new box, and I'm going to call it my array, and I'm going to just create some dummy array of numbers. If we say type of my array here, we get back an object, because under the hood, the array is actually an object as far as JavaScript is concerned. So we can actually go console.log my array, and we can see, okay, this is sort of like how JavaScript builds an array. It actually turns out that each position in the array is a property, and each property has a value. And under this proto underscore, this is basically all of the methods that come out of the box that we get with an array that we can use. And the reason why these are methods is because the array is an object. So you can see we have all of these different things that are stored in different mini boxes inside of the object, essentially. And one of these is called push. So push is a function. It takes an argument. It takes an argument, and that's the thing that gets pushed into that array. So we might have seen these things pop up lots of times before. The console.log is the most obvious example, but there are a couple of others that we've used already. So just be aware, fun fact, hopefully makes it easier to understand what's going on with all this code. Okay, so that's it for this lecture. This week's homework, as usual, we'll have some more free code camp exercises to try out lots of the syntax. There was a whole host of new stuff that got thrown at you this week, so definitely practice it to make sure that it's okay. And yeah, in the homework in general, in the bonus exercises in particular, you'll be doing lots of actual programming that will hopefully be super fun. So yeah, through practice, you'll get better and better at this. So do check that out if you have time for the week.